So good evening students, welcome you all to my next class on dynamics. So in last class we solved 4 problems based on components of velocity and acceleration along radial and transverse direction. Besides this we have taken the topics angular velocity and angular acceleration. So let's solve 2 more problems based on the same topic. So see the first problem. The velocity of a particle along and perpendicular to the radius vector from a fixed origin are A and B. Find the acceleration along and perpendicular to the radius. Also find the path of the particle. So just to see the question, in this question it is given that the velocity along and perpendicular to the radius vector is given, and it is given as A and B. So in this case velocity along and perpendicular to the radius vector means it is the components of velocity along the radial and transverse direction. So with the help of this we have to find out the components of radial acceleration and transverse acceleration. So you know that the expression for components of radial velocity is given by r dot. So according to the given question here, the components of radial velocity r dot is equal to A, and the components of velocity along the transverse direction is what? It is given by r theta dot. So r theta dot is equal to B. Now with the help of these two given condition we have to find out the components of radial acceleration and transverse acceleration. So first let's find out the radial acceleration. So you know that the expression for radial expression is denoted by f of r, and f of r is given by what? It is r double dot minus r theta dot square. So what is the expression for r double dot? See, r dot is equal to A. So if you r dot is equal to A means it is a constant. If you differentiate this one r dot once again, then you'll get r double dot. So differentiation of a constant thing you will get 0. So the value of r double dot you will get 0. Now this r you keep as it is. Theta dot square we can find out from equation 2. So see, theta dot r theta dot is equal to B. So from this what you will get? Theta dot is equal to B by r. So substitute this one in place of theta dot. So what you will get? It is 0 minus r minus b square by r square. So after simplifying what you will get? It is minus b square by r. So this one will give you the radial acceleration. That means the components of radial acceleration. So next we have to find out the transverse acceleration perpendicular to the radius. See, we have to find out the acceleration along and perpendicular to the radius. So perpendicular to the radius means we have to find out the transverse components of transverse acceleration, and it is denoted by what? F of theta, and the expression for this it is well known to you, that is it is 1 by r, then it is d dt of what? R square theta dot. So here say r square you keep as it is. For theta dot we can write it is b by r from equation 2, b by r. So b is a constant you can take outside. So if you take b outside, what you will get? It is b by r, then it is dr by d, you will get dr by dt. So dr by dt is equal to what? It is r dot. And what is the expression for r dot from equation 1? It is A. So from this what is the expression for transverse components of transverse acceleration? You will get f of theta is equal to what? It is AB by r. So this way we can find out the components of velocity along components of acceleration along the radial and transverse direction. So next we have to find out the path of the particle also. So in order to find out the path of the particle, what you have to do? You just divide equation 1 by 2. So if you divide equation 1 by 2, what you will get? It is r dot by r theta dot is equal to A by B. So you are getting a differential equation involving two variables r and theta. So r dot means what? It is dr by dt, and theta dot means d theta by dt. So if you simplify this one, so from this what we can write? It is dr by r d theta is equal to what? A by b. So we have to solve this equation by the method of separation of variables. So we can write this equation as dr by r. If you separate the variables, dr by r is equal to what? It is A by b d theta. So after integrating, what is the integration of dr by r? It is log of r. A by b is a constant, so integration of d theta is theta. With that you have to write down the constant of integration, as because left hand side we are getting log of r, so the constant of integration also will write in the similar manner, so it will be log of c. So after simplifying, if you take log of c to your left hand side, so you know the laws of logarithm, log m minus log n is equal to what? Log m by n. So we can write log r by c is equal to what? A by b, then it is theta. So from logarithmic form we can write down the exponential form also. So what is the exponential form of this? If you want to write down the exponential form, it is r by c is equal to e to the power a by b theta. So if you cross multiply, ultimately you will get r is equal to what? C, then e to the power a by b theta. So this equation will give you the equation of the path of the particle. So this way we can solve this problem. So let's solve another problem which is similar to this. Okay, see the next problem. The velocity of a particle along and perpendicular to radius vector from the fixed origin are lambda r square and mu theta square. Show that the path is lambda by theta is equal to mu by 2r square plus c. Also prove that the radial and transverse accelerations are, so the radial acceleration is given by this expression twice lambda square r cube minus mu square theta to the power 4 by r, and transverse acceleration is given by lambda mu r theta square plus twice mu square r theta cube by r. So this problem is similar to the previous problem. So but here first we will find out the equation of the path of the particle. So here see what is given, the components of velocity along the radial and transverse direction is given. So components of velocity along radial direction is given by r dot. So what is r dot according to the question? R dot is equal to lambda r square, and the components of transverse velocity is r theta dot, and it is given according to question r theta dot is equal to what? It is mu theta square. Now to find out the equation of the path, what you have to do, just similar to the previous problem, we have to divide equation 1 by 2. So if you divide equation 1 by 2, ultimately you will get a differential equation involving two variables r and theta. So this differential equation also we can solve by the method of separation of variables. So how will you proceed? See, in the same manner, you will get r dot by r theta dot is equal to what? Lambda r square by mu theta square. So from this we can write dr by what? R d theta is equal to lambda r square by mu theta square. So take the help of the method of separation of variables. So this we can write, if you cross multiply here mu, that is dr by r cube is equal to what? It is lambda d theta by theta square. So this one is integrable. So after integration, what you will get? Now integrate this one. So so in order to integrate this one, so we can write this way also. It is mu r to the power minus 3 dr is equal to what? Lambda theta to the power minus 2 d theta. So mu is a constant, mu and lambda are constant. So if you integrate this one, what you will get? It is minus mu by 2 r square is equal to what? Minus lambda by theta plus constant of integration. So this time you bring to your left hand side, so ultimately you will get the required expression, and this left hand side you transfer to the right hand side. So what you will get? Lambda by theta is equal to mu by 2r square plus c. So which is the required equation of the path of the particle. So now we have to find out, next part we have to find out the radial and transverse acceleration. So see the second part. So you know the components of radial velocity r dot is equal to lambda r square. So from this we can find out r double dot. So that means you have to differentiate this one with respect to t once again. So what you will get? It is twice lambda r. Lambda is a constant, so if you differentiate this r square, what you will get? It is twice r, so twice lambda r, then it is r dot. So again r dot is equal to lambda r square, so in place of r dot what we can write? Lambda r square. So after simplifying you will get twice lambda square r cube. Okay, next the transverse components of velocity is given by what? It is r theta dot, and what is the expression according to the question? It is mu theta square. So from this you find out theta dot. Theta dot is equal to what? It is mu theta square by r. Okay, now let's find out the radial acceleration. It is denoted by f of r, and the expression for this is what? R double dot minus r theta dot square. So r double dot already we have calculated it is twice lambda square r cube, so twice lambda square r cube minus r theta dot, also you know mu theta square by r, so it is square is there, so what will get mu square by theta to the power 4 by r square. So after simplifying you will get twice lambda square r cube minus mu square theta to the power 4 by r. So this way you will get the radial acceleration or the components of radial acceleration. Next we have to find out the components of transverse acceleration. So it is denoted by f of theta, and the expression for this is what? It is just to say it is 1 by r then d dt of r square theta dot. Okay, so for theta dot we can write mu theta square by r. So replace theta dot by mu theta square by r. Constant thing you take outside. So what you will get? It is mu by r then d dt of r theta square. So now here we have to differentiate r theta square with respect to t. So here we have to apply the product rule of differentiation. See, I'm keeping first function as it is. If you differentiate theta square, what you will get? It is twice theta then theta dot plus second function as it is, then you will get r dot. Okay, now in place of theta dot again we can write it as mu theta square by r, and in place of r dot we can write lambda r square. So after simplifying, what you will get? You just simplify, multiply with mu by r both the terms. So ultimately after simplifying you will get lambda mu r theta square plus twice mu square theta cube by r. So this is the components of transverse acceleration. So you just go through the question, see what you have to prove. The equation of the path is lambda by theta is equal to mu 2r square plus c. So you are getting that required expression, and beside this we have to show that the radial and transverse accelerations are given by this expression. So this way we can solve this problem. So I think it is understandable. In next class we'll solve 2 more problems based on the same topic. Thank you.